Hello, welcome to Physics Recipes. In today's lecture, we'll be practicing some numerical questions based on the earlier learned recipes. So, before that, thought of the day is never means I can't say that you never lose motivation. There are some days when you are demotivated, but remember that whenever you are demotivated, just recall that why you have started. That's all. And you will again get your energy back and can start working. All right. So let us begin. So the first question is a body is projected upward with initial velocity u against air resistance which is proportional to square of velocity. Determine the height to which the body will rise. सो पहले क्वेश्चन समझ लेते हैं. एक बॉडी है, लेट्स से दिस इज अ बॉडी. इट इज प्रोजेक्टेड अपवर्ड. ओके, सो and the gravity of course acts downward. This is mg, and there is a force which is air resistance that will act of course downward. It is opposite to motion. Okay, and this is a net acceleration, so I can write it as ma, and this is air resistance force. Okay, and this is given as proportional to v square. Uh, let us say k is the constant, or let's say k dash. All right, so let us write equation of motion. Okay, so how do we write? M a is equal to minus mg minus k dash v square. So this acceleration term I can write it as dx square by dt square, and I'll divide it by m, so I'll get minus g minus, यहाँ पर क्या आ जाएगा, k dash by m. Let's write only k v square, where k is equal to k dash by m. Okay, now since there are three variables, if you see this equation of motion, x, t, and v square. Okay, so we'll have to convert these three variable things into two variables. So we can write dx square by dt square equal to v dv by dx. This I have told in the previous lecture. So we can write this acceleration like this. Okay, so now the equation becomes v dv by dx minus g minus kv square. And if you see, we wanted to find the distance, means the height to which the body can rise. All right, so it is a first order differential equation, and we can separate the variables, right? So if I do v dv, और जो ये वाला टर्म है अगर मैं इसको इधर लेकर आ जाऊं, g प्लस के वी स्क्वायर इज इक्वल टू माइनस डी एक्स. All right, so now here it is a, if I can make the derivative in the numerator of this term, then I can take the integration as log of the denominator term. right? So let me take the k out. So I'll just rearrange 1 by k integration 2v g by k plus v square dv is equal to minus dx. Alright, so we wanted the derivative of this v square, because here v is the variable, so 2v is its derivative which is in the numerator. So how means in integration I can take the log of this term. So what do I get? And here 2 I missed. So 1 by 2k log of g by k plus v square is equal to minus x. Fine. Plus some constant. Okay. So now the body is projected upward. So if I okay, so if I remove this log term, so how do I get it? Um g by k plus v square is equal to minus 2kx. I'll get here, let's say c e to the power minus 2k x. Here also I'll get 2k, but since c is a constant, we can means have all the constant together. So finally, now let us try to find the value of c. So say when x is equal to 0, v was initial velocity, and it is given in the question itself that we have the initial velocity. So when the body was projected upward, its initial velocity is u. So this implies c is equal to g by k plus u square. Okay, and this g by k term, let me use, let's say g by k is equal to lambda square. So if I put in the above equation, what do I get? Lambda square plus v square upon lambda square plus u square is equal to e to the power minus 2gx by lambda square. Okay, now we wanted to find the height, determine the height to which the body will rise. So let's say we can first find v square from this equation. What do we get is lambda square plus u square e to the power minus 2gx by lambda square minus lambda square. This is the velocity. Now, the height of the body to which it rises can be found by putting the value, because at the maximum height, the final velocity term is 0. So, let me put v equal to 0 will give us maximum height. Okay, so if I put here mm, lambda square, so the final answer that I'll get is x is equal to lambda square 2g ln 1 plus u square by lambda square. Now instead of x, let's write h. That is, h is the maximum height. See, in this equation, we put x is equal to h in this equation and v equal to 0, and we find the value of this h. So on rearrangement, you will get this answer. Okay, so this was our final answer. Okay, let's go to the second question. Under the assumption of air resistance proportional to square of velocity, find find a loss in kinetic energy when a body is projected upward with initial velocity u and return to point of projection. So from the previous question, see, this question and that was same, but the difference was we have just only targeted that the body is moving upward and say it is reaching somewhere here, that we have taken only ascent part. Now here, since हमें काइनेटिक एनर्जी डिफरेंस या लॉस इन काइनेटिक एनर्जी फाइंड करना है, दैट दिस whole motion we have to consider along descent too. Okay, so the height of the body and the velocity that we have calculated in the earlier problem हम यहीं से directly ले लेंगे, दोबारा नहीं करेंगे. Okay, so let me write the particle reaches the height is h is equal to lambda square by 2g ln 1 minus plus u square by lambda square. Okay, and the velocity term is this one. So, and this is for the upward motion. Okay, for upward motion, velocity at any point. Okay, v square is equal to lambda square plus u square e to the power minus 2gx 2gx by lambda square minus lambda square. Okay, now we have to calculate this velocity for descent too, and then we can find the loss in kinetic energy. So for downward motion, now we are not going to calculate means all the means from the starting itself we have this expression, and from here itself we can find the velocity term. Okay, now First, see, in the previous question, body upward move कर रही थी, air resistance was downward, okay, and gravity was also downward. This is drag, drag, and this is mg, and this was the net acceleration. Fine. Now, in this was case of ascent. Okay. Now for descent, if we want to find, the body was coming downward, so the air resistance was upward. This is air drag, and net acceleration is downward, and mg, the gravity, is also downward. So only the difference will come in the air resistance term. Okay. In the air resistance term is denoted by this lambda square, right? No, no, sorry, this term. So only the sign will get changed. So the air resistance term will have opposite sign in the, means as we compared to the previous question. So for downward motion, initial velocity will become 0. That means in this question, u will become 0, and we get v square is equal to, means the sign of all this terms will get, just we have to multiply it by minus sign. Okay, so it will come like lambda square 1 minus e to the power minus 2gx by lambda square. Okay, all fine. Okay, so this is the velocity. Now we have to find the difference in the kinetic energy, means the loss in kinetic energy. So velocity of a body, so velocity of a body when it reaches the point of projection is found by putting oh sorry x is equal to h. Okay, so here v square is equal to lambda square 1 minus exponential of 2g by lambda square into x, means h we want to find, and this is our h value. Okay, so lambda square upon 2g ln of 1 plus u square by lambda square, first bracket, second bracket, third bracket, and fourth one. Okay, so if we solve it, we can find, means just simplify this, lambda square 1 minus exponential, this and this get cancelled, this and this also get cancelled. Okay, so exponential and log also gets cancelled. Oh sorry, I have missed here a minus sign. It was minus, yes, minus 2gx. So here it will come minus log of 1 plus u square by lambda square. Okay, now in order, we know that exponential and log gets cancelled. If we if we take this minus 1 to the power of this, so it will become 1 minus exponential into log of 1 plus u square by lambda square minus 1. Okay, so this will get simplifies to 1 minus lambda square plus u square. So this term becomes lambda square u square lambda square plus u square. Okay, this gets simplifies to this term. Now we know the final velocity, okay, when the body is coming back to the projection point. Okay, so we have to find finally loss in kinetic energy. So which is given by initial kinetic energy minus final kinetic energy. Okay, so if I write this value of V in this, so I'll get m by 2 u square minus lambda square upon lambda square plus u square. So finally, if I means multiply this and find, so final answer I'll get m u to the power 4 upon 2 lambda square plus u square. So that is our final answer and the loss in the kinetic energy. Okay, so let's get to third next question. A small raindrop of mass m experiences a viscous drag which is given minus pv proportional to its instantaneous velocity v. If it starts from rest at the height h, its speed after a time. So you can means it is starting from initial velocity 0, t is equal to 0. Okay, so it is falling down. So its next net acceleration is downward and air resistance is upward. This is air drag. We can call drag or resistance, air resistance, both are the same thing. This is gravity and this is net acceleration. Okay, so these many things are given. So let's try to do it. M dv by dt is equal to mg minus, here it is given bv, so let's write bv. Okay, so again here we can do divide by mass and variable separation, then we'll get dv upon g minus b by m into v is equal to dt. Now it has stated that uh, from initial velocity is 0, so when we integrate it, we can take the limits 0 to v and we have to find the speed after the time t. So uh, this is the final velocity v that we have to find. and the time we take 0 to t. Okay, and now if we integrate, we'll get the answer. So here you see, here is a term v, and I want, in order to integrate, इस टर्म का डेरिवेटिव ऊपर होना चाहिए. फाइन. तो लेट अस रीअरेंज दैट. हमें डेरिवेटिव में क्या चाहिए? माइनस बी बाय एम होना चाहिए, बट यहाँ है नहीं, हम लेकर आ रहे हैं, तो हम क्या करेंगे? माइनस एम बाय बी से मल्टीप्लाई कर देंगे, सो दैट इट विल गेट कैंसिल. And here it is minus p by m into v, and this will become simply t. Fine. So now we take log. Now we are able to take the log or ln, you can write g minus b by m into equal to t. Now take these terms here. So I'll get g minus b by m v is equal to minus bt by m. Okay, so if we remove this log, we'll get is equal to e to the power minus bt by m. Now you find the velocity just by rearranging the terms. We'll finally get mg by b 1 minus e to the power minus bt by m. Okay, that is simply the answer to the question. All right, so see how easy it was. Fine. And similar questions are being asked in the exams. So let us go to another question. So the question is, the time evolution of coordinate x of a particle is described by equation. So this ये equation हमें दिया गया है और पूछा गया है कि जब omega is greater than a, the particle will, and these are the four options. This question has been asked in net exam. So let's try to do, how do we solve the problem. So given differential equation is t power 4x dt power 4 plus 2 omega square d square x by dt square plus omega to the power 4 minus a to the power 4 x equal to 0. Okay, so we have to solve it the approach that I have discussed in the last lecture, t to the power 4, where d is d by dt plus 2 omega square d square plus omega power 4 minus a power, all into x equal to 0. So now x can't be 0, so we can take this d power 4 plus 2 omega square d square plus omega power 4 minus a power 4 equal to 0. Okay, and now if you see this term from here, to here. If you see it, it is nothing but this term is equal to d square plus omega square whole square. Okay, so we can write this as d square plus omega square whole square minus a power 4, which is equal to 0. Okay, and now we have to just simply find the roots of this equation. So it will be d square plus omega square is equal to plus minus a square. Now further we have to find the roots, which is nothing but d square is equal to minus omega square plus minus a square. Okay, so we'll get two equation means like this, minus a square and d square is just I'm taking the plus minus signs separately, plus a square. Fine. Now we know that we can write minus 1 is equal to I square. Okay, so here d square, यहाँ पे माइनस कॉमन निकाल लेंगे तो वो आई स्क्वायर हो जाएगा डी स्क्वायर प्लस ए स्क्वायर. Fine. And now let's take the square root. So d will be plus minus I omega square plus a square. Okay. And here similar thing we do is d square is equal to I square. यहाँ पे ब्रैकेट में क्या आ जाएगा ओमेगा स्क्वायर माइनस ए स्क्वायर, हमने माइनस साइन कॉमन निकाल लिया है तो d इज इक्वल टू प्लस माइनस आई omega square minus a square in a square root. So these are the roots. Okay, so if you अगर आप देखें तो हमें दो रूट्स ये मिले हैं और दो रूट्स ये मिले हैं, तो और सारे ही रूट्स all roots are distinct means different है सारे roots. तो जब अगर सारे रूट्स डिफरेंट होते हैं तो हम कैसे लिखते हैं सॉल्यूशन x, हम जनरल सॉल्यूशन कैसे लिखते हैं x इज इक्वल टू c1 e टू द पावर, मतलब मान लो अगर r1 रूट है तो r1t प्लस c2 e टू द पावर r2t प्लस लाइक दैट. Okay, so in this case the general solution will become c1 e to the power I under root omega square plus a square into t plus c2 e to the power minus I omega plus a square into t. Third root will be c3 e to the power I under root omega square minus a square into t plus c4 e to the power minus I omega square. Let me remove this. Minus a square into t. Now we got this solution. Okay, but in the options if you see there is no exponential thing, right? We are getting it. Now, if you recollect, e to the power I theta can be written as cos theta plus I sin theta, means plus or minus. So yeah, I'll get here plus minus. So sine and cos represents the oscillations. Okay. So now if you the see this options, so you will get the option C as oscillating about origin. So it is the right answer. Okay. So this, see how simple it was, the question which was asked in the net exam. Okay. So it is as simple as that. All right. So this is all for today. Thank you and happy learning.